In this video, we're going to look at processing tabular data using the tabular data processor in RAMP. So processing in this context means anything that changes, calculates, or adds field values to a tabular dataset, or anything that filters tabular data records. The methods in this processor are useful for processing tabular data files that are too large to handle in a spreadsheet editor such as Excel. In a previous video, we addressed the tabular data structures that RAMP expects and uses and how they're implemented through the standardized ASCII CSV format. So if you're unfamiliar with that format and what that means, go and have a look at some of the previous videos where we looked at how to reformat ASCII data into these standardized structures. So if I start the tabular data processor, you'll see a whole series of different methods. And in this video, we're going to address and have a look at, through example, the add field method, the remove non-numeric records, how to convert between dates and times and POSIX. We're going to look at how to calculate distance and bearing between two sets of coordinates in a tabular data set. We're going to look at how to recode values, append values from a raster into tabular data, how to round values in a column, and how to extract data from a tabular data set to a new one using ranges or flags of values in a particular column. We're going to very quickly also at the end talk about how to decimate data in a tabular data set. What we're not going to address is any of the join methods, and we are only very briefly going to look at how to calculate data or fields from the tabular data set using the tabular data calculator in RAMP. So to explain some of these methods, we're going to use an example data set that we will process with a certain objective in mind that will show you how to use these methods. Let's first have a look at what that data set looks like. So here it is, and it's actually a data set that shows or lists the location of various vessels or boats within a certain area of interest. So I have an ID field that uniquely identifies the vessel. I have a POSIX field, which is a numerically encoded timestamp, and I have the latitude and longitude coordinate values for those vessels. I also have a series of other fields here that we probably won't use. Let's look now at what the objectives are going to be in this video tutorial that will demonstrate the methods. So we're going to attempt to calculate the distance of each vessel from a central or focal vessel. We're going to round this distance to 2 decimal places. We're going to assign a water depth to each vessel position. We're going to calculate the age of the vessel report, so how old the report for each vessel is based on the time that we fetched the information from the XML originally. We're going to flag the records in the tabular data set based on the age, so based on how old those reports are. And then we're going to extract data for good vessels based on this an age threshold. And lastly, we're going to look at decimating tabular data. So coming back to my data set, I will not use the heading, rate of turn, speed over ground, or course over ground fields. And I've noticed just scanning through the file that in fact I also have some data in my latitude and longitude fields that contain non-numeric values. So what we're going to do first in RAMP is we're going to delete the the fields that we're not going to use, and we're going to try and exclude any records that contain non-numeric data. So let's first handle that non-numeric data record. The remove non-numeric records method in the processor does just that. So I'll pick my input file, I will pick the fields that I want to declare as having to be numeric, so in this case it's the latitude and longitude field, and I will create a new output file because I believe this method requires that you create a new file. So we'll call it vessels_clean, and we'll run that, and it will have removed that non-numeric or the non-numeric records in that data set. So let's run that. Okay, and it's done. Let's also now use the delete fields method to remove the fields that we don't want to use. So I've just selected that last file we created, and it's asking me, okay, which fields would you like to delete? So I'm going to delete heading, rate of turn, speed over ground, and course over ground, and I'm going to get it to override that file. So let's click OK, and it's done. Let's now have a look at what that data set looks like now. Okay, here it is, and you'll notice that scanning through, there appears to be no non-numeric records in the latitude and longitude fields, and those other 4 fields that we deleted are no longer present. Going back to our objectives, the first thing we want to do now that we have some clean data is calculate the distance of each vessel from a central vessel. So we're going to assume that the first vessel here will be that central or focal vessel, and I'm going to copy its coordinates. And then we're going to go back to the ramp processor and see what what methods we're going to use to do this distance calculation. Okay, so back in the processor, we're going to use the calculate proximity distance and bearing method. But before we do that, that method requires that we have 2 sets of coordinate fields. So we're going to have to define 2 new fields that contain the fixed position of the focal vessel. So let's do that using the add field. And the first field we're going to add to this data set is going to be called C lat, so the central latitude, and it's going to have the value that we copied from the tabular data set before for that record, and we're going to override this file here. Okay, now we're going to do it again, and we're going to add the central longitude as a default value. Will be that's the value we copied from before, and we're going to override that file. Okay, let's have a look at what that table looks like now. And you will notice that it's added the CLAT and the CLON fields in there. So we have the latitude and longitude of each vessel, and we have a fixed value here that's based on the coordinates of the first vessel. So let's go back to the processor and now calculate the distance between these 2 sets of coordinates. So to do that, I'm going to use the calculate proximity method. I'm going to select my input file, and I am going to tell it that the first set of coordinates, the x1 and y1, come from the longitude and latitude fields, and the second set come from the central longitude or CLON and central latitude field. Now, because these coordinates are geographical, I also need to specify a ellipsoid, and it's asking me now what my output fields are going to be. So this will calculate both the distance or proximity and also the bearing from x1, y1 to x2, y2. So now let's choose our output and run it. Let's have a look at the results. So here are the results, and you can see that it's added the proximity and bearing field, and as expected, the proximity and bearing for the first point is 0 because the central latitude and longitude is the same as the latitude and longitude because that was the focal vessel that we used. Having a look back at our objectives, now we wanted to round the distance or the proximity field to 2 decimal places. So we're going to do 2 things. We're going to drop the bearing field, we're going to rename proximity to distance, and then we're going to round that value. So let's look at how we would do that. Okay, so firstly we're going to delete the field that we don't want, and that was the bearing field. and then we're going to rename the proximity field to distance. Okay, and now we want to round that distance field. So we'll use the round method. And we're going to round the distance field. Let's just make it round to 1 decimal place. Okay, let's go have a look at the results. So you'll notice that the distance field is now called the distance field, and it has been rounded to 1 decimal place. Let's look at our next objective. So that was to assign a water depth to each vessel position in this tabular data set. Let's go back to RAMP and see how we're going to do that. So let's firstly look at the source for our water depths. I've already added the Geoscience Australia topographic and bathymetric 250 meter model. So we're going to use this as the basis for the water depths. I know that most of those vessels in our tabular data set are within this area of interest. So this will be our source. So if I open the tabular data processor, I see that I have a method called append values from raster. So let's choose our tabular data set. Let's choose the new field name. So we're going to call it water depth. And let's choose the longitude and the latitude as the X and Y source fields. And the raster we're going to choose is the OzTopo raster. And we're going to output to this file. Okay, let's have a look at the results. And you will see that it's now added this water depth field and assigned the water depth from that raster topobathymetric model to these positions. So let's revisit our objectives. We've assigned the water depth, but now we wanted to calculate the age of the vessel reports. So looking at my data set, I have this field called POSIX, and this contains the POSIX time for the vessel reported position. POSIX time is actually the number of elapsed seconds from a given epoch, and traditionally this epoch is the 1st of January 1970. So it's not very human readable. I can't look at that and say, oh yeah, that was last week. So what we're going to do first is we're going to convert the POSIX to a human readable date. Let's have a look at how we can do that in RAMP. So in RAMP, in the tabular data processor, I have a series of methods that allow me to convert between dates and times and POSIX times. So let's convert a POSIX time to a real date time. So I'll pick my input file. I will tell it that the POSIX field is called POSIX. Now it's asking me for how I would like to format my output time. So this is a Microsoft date time format string, so you can look that up on the web if you're unfamiliar with this notation. But this is going to give me a nice, long, unambiguous 24-hour date time format. It asks me what my epoch for the POSIX field is, and this is the 1st of January 1970. And it asks me what I want the output field to be called. So we'll just call it date time. Let's run it, and let's have a look at the results now. And you will see it's added the date time field in this nice non-ambiguous format. And I can see that most of these were reported on the 23rd of December, sometime around or just after midnight. So that's interesting. And I know that I actually fetched this at about 10 past midnight on the 23rd. So what we can do now is insert a new field in here that has my fetch time. So that'll be the 23rd of December 2020 at 000, let's say 0007 in the morning. So let's just add a new field in here. And the new field will be called fetched. And the default value will be 23rd December 2020 at 000700. And let's write that. Okay, great. You can see it's now added that field to the tabular dataset. But what I want to do is calculate the age, so I really want to take this away from this. Now the way to do that is to have this as a POSIX time and then take that new POSIX time away from the actual reported POSIX time. So now we want to convert the fetched field to a POSIX time. So let's use the convert date time to POSIX, and we will tell it to use the fetched field as the source. It's asking me for what the format is of that date time. If I leave it blank, it will use some assumptions, and it will be able to pass that generally, particularly if it's a fairly standard and unambiguous date time format, which it is. Again, it's asking us for the epoch, and what do I want to call the new output field? So we'll call it fetch POSIX and output. Let's have a look. And indeed, it's now calculated the appropriate POSIX time. So let's take this number and minus it from this number to give us an age. So to do this, we're briefly going to use the tabular data calculator tool in RAMP. So let's open that, and we will look at this tool in a lot more detail in another video. But for the meantime, we're just going to use it quickly. So let's define my input file, vessels clean. It's listed now all the fields that I have available to me, and it's asking me for a new output file. Now, unfortunately, I can't just override this, so I'm going to put a new dataset here called vessels clean age. It needs to be written to a new dataset, and I'm going to calculate the age field, so I'll call the field age. Now, all I need to do is use my available value fields here as arguments to my processor function. So I'm going to say I have an integer which is fetch POSIX, and I have an integer which is POSIX. Now I will calculate int age equals fetch POSIX minus POSIX, and I'm going to return the age to the function. Let's run this. So you can see now I have my age field in here, which is the age of this date minus this date, or the date that we fetched the XML information and the last time that was reported by any of those vessels. If we go and have a look at our objectives, one of the things that we wanted to do was assign a flag to each of these vessel records depending on what that age actually is. So let's look at how we might do that in RAMP. So in the tabular data processor, I have a method called Recode. This allows me to take a given field in a tabular data set and apply a lookup table to it. So the lookup table defines a range of values and a subsequent lookup value. So firstly, we're going to have to create our lookup table, and this is implemented through a RAMP histogram definition file. So we're going to use the histogram definition editor to create a lookup table for the Recode. And we're going to do this based on vessel age. So we're going to define some ranges where we think vessel age reports are good and vessel age reports are bad. So here's my histogram definition editor, and I've already put in here some values. So from 0 to 5,000 seconds is 1, that's good. 5,000 to 60,000 is 0, that's like, yeah, average. And 60,000 and above, so this is a stupidly large value, will become a -1. So let's save this, and let's go back to the Recode choose my input file, choose my histogram, choose the input field, so it's going to be age, and we're going to create a new field called class. Now you can see in my data set that we've added this field called class, and some of the values fell out of range, so they've been given an NA. So these are good, these are not good. There might be some zeros in here. There's the odd zero, which is like average, and then some of these are out of range, which probably means they're even worse than a -1. So looking back at our objectives, we've managed to assign a flag. And now we want to extract the good vessel records. So if you remember, these are records that are flagged with the value 1. And we're going to extract those to a new file. So to do that, I'm going to use the extract methods in the tabular data processor. So I can extract things based on a value range. So that is a numeric minimum and maximum value range, and if the value of a given field falls within that range, it will be either extracted or included or excluded from the output dataset. We could do this using the age field, but I'm going to look at the extract flag records method, which will allow us to look at our class field and extract any of the class 1, i.e. good, vessel records. So I'm going to specify my input. The field I want to look at is class, and the flag I want to use is the number 1. And then it asks me for my flag match type. So I'm going to say it has to start with the number 1, because I also have -1s in there, and I don't want to get those as well, because they still contain the character 1. So we're going to say starts with 1. Is it case sensitive? True. Should we trim the input? That means just clean it up for if there are sort of non-printable white spaces and that sort of thing around it. We're saying this is inclusive. Yes. We want to include anything that's flagged with 1. And then the output file will be vessel clean age extract. And as you can see, it's extracted all of the class 1, only the class 1 records. So if we look at our objectives, we've completed all of the objectives here except the last one, which is looking at how to decimate tabular data. So I'm not going to do this by example, but I am going to talk you through what the processes are involved in decimating tabular data. So again, in the tabular data processor, there are two methods in here called decimate records skip and decimate records threshold. Decimating records by skipping basically just says, hey, extract every other or every 3 or 4 or 5 or however every n records you define as input into this property. So that's decimating by skipping, a very simple method. The other one is to decimate by threshold. So if you imagine you had a data set where the sequence of the data set is important, so it might be ordered by time, for example, or distance perhaps, then you can look at a threshold of values between the current record and the previous record. So I would typically define for example, I would typically define a field. Let's take the POSIX field, and I'd have a threshold of 2. So that would mean that the POSIX value from my current record minus the value from the previous record has to be less than 2. And then the output file. So that's just very quickly how decimation works in the tabular data processors. So hopefully this video has been useful to you and has stepped you through some of the common methods that are available in the tabular data processor. Thanks for watching.